Hello, everyone, and welcome to this podcast from the Light Review. And we're talking with Steve Saville from Clevertronics. And today we're going to be talking about something a little bit different. If you've followed our series thus far, you'll know that we've been talking about the importance of emergency lighting, the importance of system design. Well, we're going to go a little bit, I suppose, off-piste, Steve, in a way, because we're going to be talking about something that an awful lot of people don't know anything about. Steve, tell us all about dynamic signage.
Okay, so dynamic signage is essentially an evacuation system that's built into conventional exit signage. And the whole purpose is to improve the visibility of exit signage to allow us to evacuate a building in the quickest and the safest manner possible. And in doing so, it's also allowing us to utilize more available fire exit routes than what people are aware of, because you'll see through this podcast how research has suggested that the exit signs are probably not as effective as we may imagine.
Right. Okay. Well, that's actually quite scary when you think about it, because we all think that we're living in this safety blanket that if the emergency lighting signage is okay, that we all know where we're going.
Absolutely. I mean, we know ourselves, if we're in a building and the fire alarm goes, or there's a voice activation to say, please evacuate the building, because we live in the industry, the first thing we will do is what we always do is look around first to see if it's genuine. You know, is it a real evacuation? And then we would look for the exit signs. But apparently research has shown that that is not always the case. So there's been lots of research done independently of emergency lighting manufacturers and lighting manufacturers in general. The biggest research is from the Fire Safety Engineering Group, based in University of Greenwich. Now, they've been working in the fire safety engineering industry for over 20 years, and over the last decade, they've been looking at evacuation and the signage itself. They've done lots of experimental, computational research. They've also looked at real-life historical disasters. And they've also conducted full-scale trials, human trials. And essentially what they've done throughout all their research is they found that on average, believe it or not, only 38% of people actually notice or recognize an exit sign, which is a ridiculously low number thinking about it this day and age. I would have thought it was much higher before I read this paper. So they said, well, when they also looked at that research, when people did notice that sign, almost 100% of people then followed it. So they said, well, okay, if we want to improve safety, speed up evacuation times, there's one thing that's critically important, and that's to make sure that the exit signs during an evacuation procedure are as visible as possible. It makes perfect sense, but it's something we've not really considered before, because we're used to having the standards in place, the exit signs in the correct place with the correct viewing distance and everything else, and we assumed that was enough. But clearly this research shows that it's not. So what they did is they took it upon themselves to say, well, how can we improve that? 38% isn't good enough, but 100% almost following those signs is fantastic. So how can we improve on this situation? So they looked at a whole range of different options. They tried flashing a backlight in the back of an exit sign. They tried flashing lights in front of an exit sign to grab people's attention. But the concept that they came up with that yielded the best results had two elements of it. It was a dynamic green arrow. And as you can see here, when you do use a dynamic green arrow, the number of people who notice the exit sign jumped from the 38% previously up to 77%. That's a huge increase of people seeing that sign. And then again, almost 100% effective for people to follow that sign to the quickest or the safest escape route. So it had temporal and spatial elements to the sign. Right. So you had the LEDs that were illuminating. So basically, if you had a sign saying evacuate to the right, it would the LEDs would illuminate in that direction, just like you see on the indicators of some fancy cars these days on the motorways. They will move in the direction of travel. The arrow does the same. It illuminates the entire arrow. So not only does that improve what they call the affordance or conspicuity of the sign, but it also gives some information, as if to say, okay, this is the sign, you can see the sign, and this is the direction of travel you need to take to evacuate from that building. So they did lots of computational assessments of the sign to see how it improved things. They have some, the fire safety engineering group have some fantastic software, Smart Fire and Exodus, where they can rerun lots and lots of different scenarios to see how people would behave. But they also did, like I say, full scale evacuation. It was on a train platform in Barcelona in Spain, and you can find this actually if you search it on the internet. You can see some videos on YouTube. It's actually quite interesting. And what they did is they set up a number of cameras around the train station, had some volunteers which were taken to the train station from another station, so they weren't over familiar with the layout of the train station where the trial was taking place. They were aware they were in a trial, but they weren't aware of what exactly that trial was for. They were sort of sat out, if you like, spread out across the train station, various zones, to emulate a busy train station, if you like. And then the alarm sounded, and they recorded everybody's actions, and there was a post-trial survey to get people's reactions. And on the back of that, what they found was when people saw those signs, they did say, yep, the signs were more visible, they were more aware, and we believe we were given an instruction to follow, to evacuate to the left or evacuate to the right. So it made interesting reading. So yeah, off the back of that, that is what we call, they call a dynamic green arrow, to improve the affordance or visibility of a sign. But there's another element to dynamic signage as well. So you'll hear people talk about a red cross scenario or a red cross exit. Now, even those two elements, you don't actually need both elements to be part of your system. Some people don't want to write a negated sign into their fire strategy because they don't feel comfortable with it. But you can actually just improve your static signs to be dynamic signs to improve the visibility, just so that when a fire alarm is sounding as evacuation process, you can just have the green arrows to say, these are the exit routes, please follow them, you know, in that dynamic sort of graphical display, if you like. But yeah, the reason or the concept of the red cross is to try and guide people then out of the safest route out of a building. So for instance, again, I was talking about lots of research the fire safety engineering group had done. And one disaster which happened here in the UK, the King's Cross fire, it was evident that some people, when they were escorted away from the area of risk, if you like, were starting to evacuate from other adjoining platforms or tunnels, that by following the exit signs, it actually led them back to the place of danger or the place of high risk. So they became thinking and thought, well, maybe we can do something about that. If there are alternative escape routes and one of those has been compromised, maybe we need to look if we can change the dynamics of a sign. Maybe we should look at saying to people, this used to be a viable exit, but it's no longer viable, you should choose an alternate route. So they also did that in this train station as well. And so again, they did a lot of it computational, if you like, but they did it real life trials. And because quite often they're speaking to customers, we're talking about Red X, they say, oh, there's no way you'll change people's mindset, they'll always go that particular route. But actually the research and the testing and the trials shows different. They actually managed to get over 60%, I think, depending on which trials they're on, I think the highest was 66% of people to avoid 3 of the escape routes and exit through a designated target escape route. So people did see the red crosses and choose an alternate route. However, they also said on the application of it, if there was, they call it negative enforcement for the red cross, and they call it positive enforcement for the green dynamic arrow.
Right.
They're saying if you see a negative sign, then you should be able to see a positive sign, because if they didn't have a positive sign, then sometimes people took the risk and still went through the same route. So if you see a red X, you should be able to see a green arrow to reinforce the fact that that is the wrong way to go, and this is really the ideal route.
There are scenarios going around in my head. There really are, and here's something that's just a huge penny just dropped. There's a lovely new restaurant opened in Weymouth, and I did the lighting in it, yeah, and we did the emergency lighting in it, absolutely fine. And of course, all the conversations around emergency lighting is, why do we need it? You know, the client's going, why do I need all this stuff? And I go, because one day all the power's going to go out and people are going to be upstairs in your restaurant and they can't get out when therefore we need light. But I've just realized, of course, that's not the only case. That there are times, and very, very important times, when you want to get people out of a building very quickly, and there hasn't been a power outage. And therefore, whatever the status quo is, the fact that you've got an absolutely compliant exit sign above a staircase doesn't mean to say that people will see it.
Yeah, you're absolutely right. So if you think of say applications or areas or spaces where there's a lot of high ambient light or a lot of visual noise. So if you think, I don't know, an airport, for instance, there's signs for departures, arrivals, there's the check-in desks, there's hundreds of people, there's maybe a wall of windows down one side, and if an alarm goes and people have to evacuate, usually just head straight out of the main entrance.
Yes.
Because that's been found in the research as well. We underuse all the available exits, but overuse the main entrance. And in doing so, it can result in catastrophic and quite often fatal consequences, because trying to get hundreds of people out of one small exit can be very, very challenging and difficult indeed. In fact, the reason why Professor Edgar Lear of Fire Safety Engineering Group is quite vocal in promoting these concepts is because they've seen throughout their research that it can help to save lives. You know, we know in a real case scenario, a real fire scenario, within a matter of seconds, or if not a minute or two, some of the escape routes will be impassable depending on where the fire is. And people need to be able to navigate to be able to get out of a building safely. There's been some high-profile disasters where there was a nightclub, for instance, in the USA, in, I think it was 2003, and Rhode Island, I think it was called the Station nightclub. There was around 400 and something people in this nightclub, and there's a fire, and within a minute and a half, the main entrance was completely blocked by people trying to escape the building. And unfortunately, there was 100 people who lost their lives and 230 injured. Now, there were 4 other alternative exits, but nobody knew where they were. And this was evident because people were trying to break windows instead of just going through another exit at the back of the building. So it's and you can search the history books and you'll see similar disasters over and over again. Maybe not as bad as that one, but it was a high profile one, which was part of their research. And it really brings to the forefront the need to make all available exits as visible as possible, because if every second counts and you can save 18-25% on evacuation times, then we need to do something about that. You know, we need to make these signs more visible.
Where are we on compliance with this? I mean, I get that the sign itself is a compliant sign, but yeah, is there anything about having sort of dynamic lighting within that sign that makes it non-compliant?
So yeah, that's a very good question. So at this moment in time, there are no standards available to cover dynamic signage. As I sit on the ISIL technical committee and also the emergency lighting working group for the FIA, and we're fortunate that we've got visibility and we're being able to comment on some draft work being done by the SEN technical committee 169 working group 3, who are putting together draft documentation as we speak to try and develop standards in the future for this, because as we know, innovation always comes ahead of standards. We'd like to think it's the other way around, so everybody works safely, but innovation always is one step ahead of the standards. So the way the clients of ours who are utilizing these systems look at it is, when it's not activated, the sign should be a standard compliant sign. Okay, right. So for all intents and purposes, it's just a maintained exit sign on the wall, looks like any other, fully compliant to all the latest standards. Then when it's activated, it's then enhanced, if you like. Now, people say, oh, it's a risk because, you know, I'm having a deviation from the standards here and I'm putting my name on that. The beauty is the research I've been referring to is all publicly available. So what most people do is when they're writing that deviation, they're citing that research that's gone on by these independent experts, not some lighting manufacturer trying to sell you a new shiny thing, but by people who are actually doing it for the right purposes. And you can use that research and cite that research to say, actually, I'm improving safety massively. In fact, in some scenarios, I'm reducing evacuation times possibly by, 25%, 50%, depending on how you deploy them. So people are happy to write that in there. And same with the dynamic Red Cross. People say, oh, that's a heck of a responsibility to say, oh, you can't use that escape route anymore. But what we found is with working with fire safety engineers, they're quite happy to implement that in their designs because they're in charge of the fire strategy and they make those decisions on a daily basis. So we've done one quite recently where there's some accommodation with two stairwells. And in some areas at each side of the building, it's quite difficult to extract smoke from those areas. So what they're saying is if there's a fire in, say, I'll make it up, area A, then they want to have a Red Cross for people traveling to escape through area A when you can escape through area B quite safely. So it's those sort of scenarios, and fire safety engineers, because they've got the experience and the technical know-how to manage these things, they're quite happy into introducing them into the strategy. With the like I say, the research that's available, it then gives credence to what they're putting in their deviation. Okay.
Now, I get the arrow. I get the green LEDs, and that's absolutely fine because from what I can see, all you need is for an alarm to be sounded, and those would activate.
Yeah.
But if you've then got a situation where the building is compromised in zone A or zone B, someone or something is having to make that call.
Yep.
Now, is this being linked to smart sensors, or is it a human being on a keyboard somewhere?
Well, most manufacturers, when they have this type of range in their offer, are trying to make them as usable as possible. So trying not to sort of like choose closed protocol type systems, if you like. So for instance, ours, and I know some other manufacturers are very similar, where you can actually operate the signs with a volt-free contact, and you change whether it's open circuit to closed circuit, etc., or 24-volt DC line, because I would say 90+% of these systems with Red Cross will be connected to another system. So that's usually an addressable fire system, because you know which detector has detected the heat or the smoke. You know which zone that's in. So you can link that through class change, if you like, in the fire panel, excuse me, using input-output devices to change the state of a relay, which then changes zone A to all exits to zone A to Red Cross, all other exits to green arrow. And then if the scenario changes again, then the fire panel can move that through. But there are some who want to use their security, if you like. So if you might have security over a shopping mall or a football ground, they have visibility with CCTV absolutely everywhere, because it might not always be a fire situation. It could be a security event.
Yeah.
They could be somebody in there that could cause harm to others, and you want to evacuate, but the last thing you want to do is send people in the direction of that danger. So some people say, well, actually, for fire panel, yes, we'll have it automatically. We want a manual override to be able to say, from the security room, we want to have the south of the building set up, or the zone of the building from the south set up as Red Cross. So you'll be able to flick a switch and say, actually, the south of the building now is all the routes leading to the south of the building, should I say, and now all Red Cross activated, and all the others are green arrow. So it depends on the end user, and keeping the system flexible is key, because it allows them to deploy it in which way they like. But the majority are, as you say, connected to some sort of intelligent system, whether that's class change through an addressable fire system or through another system of some type.
Okay. Now, I think we're going to put a video on the back of this, because I know you've got a video on this, because I think, having spoken to it, we've shot up one or two slides during the process. But I think we're going to add a few more minutes onto this and actually give a video that explains people what it is. But one last thing for this little chat, Steve, is that we've never ever had to think about the choreography of evacuating a building. You go, get out, and everybody just goes, and we don't know where they go. And as you say, most of them will go the wrong way, because they'll just go the way they came in. They'll go for the big doors, and they won't go for the little doors that they're standing next to.
Yeah, you're absolutely right.
Yeah, now if we've got a dynamic system, and again, I'm really talking about the Red Cross system rather than just the green arrow, we are going to have to start planning some very, very clever choreography.
Absolutely, but believe it or not, in most scenarios, when we imagine what we're talking about here with dynamic signage and negating escape routes and non-viable escape routes versus viable escape routes, it sounds very convoluted and very difficult and complex. The reality is usually most areas only have 1 or 2 escape routes. So even in some of the largest buildings where we're looking at these, sometimes we may provide 200 or 300 fittings to a project, but only 4 dynamic signs, because they're the key escape routes over the stair areas and things like that. So it can be quite complex, but it can actually be quite simple, and you can still help protect those in the building by sending them in the safest escape route, not just the quickest, because obviously the safest will eventually be the quickest anyway. But it's a good point you mentioned. Apologies for talking over you, but there was a slide that we're going to show here where the fire safety engineering group say we've been very good historically at fire detection and then occupancy warning, and then we sound the alarms and just say go, and we expect people to know what go means. And we do, because we live and breathe the industry, and the first thing we do if we had our families with us is look for the escape route signs, the exit signs, and we would follow that. But the research has shown that's not the case. The same by having a dynamic signage system or some sort of evacuation system is like the missing link in the evacuation process. So you detect the fire or the danger, you sound the alarms, and then hopefully guide people out in the safest possible route in the quickest possible way.
This is another one of those things where the LED has opened doorways for us that we would never, ever have been able to do sensibly before.
Yeah, absolutely. I don't know how we do it without LEDs.
No one invented the LED in order that we could get out of a building more safely, let's face it.
Yeah. I mean, the only other thing I would add really on this is when you're looking at the signage, you're looking at which ones you're going to select. And you're going back to that compliance thing, because some people quite often ask the question, what if it fails? What if that signage fails? What do we do then? So we've always suggested you should have a fail-safe system. So if the LEDs fail or the system fails, then you should be left still with what we've always had, which is that static exit sign. So if the green arrow fails or the red cross, then you still always should have that green exit sign there available. If it fails so it's off, then that could be the worst case scenario where people don't know where they're supposed to travel.
Sure. Yeah.
People say, oh, well, if it goes to a static sign, then they may still evacuate in that area. So isn't that sending them in the area where there's risk? I'm saying, but what do we have now? It's an improvement what we have now, and what we have now still might do that. So hopefully the system's operating, you guide them in the right manner. If it's not, you still should show that exit sign so people have a choice and a decision to make.
Sure. Steve, this conversation is going to run and run, I think, and me and you will certainly talk some more about this in the future. But yeah, we're going to stick a little video on the end of this so that people can see what Clevertronics have been doing along with their colleagues. I hope you've enjoyed all of this, because this is pretty damned important, I think. And that's a good news story, and we look forward to hearing more about it. So thank you very much for your time and your attention, Steve. Thank you.
No problem.
And we'll be getting back together again soon.
Okay, good morning, everybody, and welcome to today's webinar by Clevertronics. I think we'll make a start. I know there are still some people joining, but I'm mindful of everybody else's time, so we'll make a start. So yeah, thank you very much for joining us today. We've had another fantastic response, so thank you for that. This week's live webinar is the third in our current series of webinars, which we'll be delivering live over the next few weeks. Be sure to like the Clevertronics UK homepage on LinkedIn to keep up to date with the latest topics and webinar dates. And today we'll be taking a look at active dynamic signage systems, and in particular why and where the need for these systems came from and the research behind it. We'll also be taking a look at our Clever EVAC system, which is designed and built in line with this research. So you will see today how these systems will not only help to improve evacuation times, but will also help to save lives. My name is Steve Saville. I'm the Technical and Project Support Manager for Clevertronics UK, and I've worked in the immersive lighting industry now for over 16 years, and I also sit in the ISIL Technical Committee. Today I'll be joined again by my colleague Michael Deuce. Michael is the Global Systems and Engineering Manager for Clevertronics. He has an electrical engineering background, specialising in control systems for immersive lighting and lighting control. Michael represents Lighting Council Australia and LG007, the Joint Standards Australia and New Zealand Committee for Emergency Lighting. He's also a participating member of the IEC Joint Working Group 2, which is the IEC working group responsible for IEC 60598-222 for emergency luminaires and 61347 2-7 for control gear, which ultimately become the British and European standards we all work to today. Michael is also currently the project leader for Joint Working Group 2 for the integration of lithium batteries into these standards for emergency lighting. So let's take a look at the format of today's presentation. So first of all, as usual, we'll talk very briefly about Clevertronics and who we are for those who don't know or not aware. Then we'll move into the main body of the presentation, where we'll take a look at the research and the reason why adaptive dynamic signage systems should be considered to improve safety. Michael will then take you through the technical aspects of the Clever EVAC system and delve a little deeper into the research and the results and the findings of that research. The presentation should last around 30 minutes, and there'll be an answer and question session at the end of the presentation. We'll be initially answering some frequently asked questions, but also questions raised by you here today. So if you do have a question, you should see a Q&A icon at the bottom middle of your screen. If you click on that, then a small text box should open and it should allow you to type your question there. We hope to be able to answer all your questions raised today, but if we do run out of time, we'll be happy to respond directly after the presentation. So Clevertronics, who are Clevertronics? Well, for over 20 years, Clevertronics have and continue to be a market-leading emergency luminaire and systems manufacturer, with over 50% market share in Australia and New Zealand, and approximately 70% market share in the project sector in those regions. Clevertronics came to the UK in late 2018, where we have an office and a warehouse facility based in London with plenty of UK stock. We also have sales and project support throughout the UK as well. We're considered by our peers to be pioneers in lithium battery technology and in delivering active dynamic signage systems into real products and systems. So let's move on to the presentation. So, active dynamic signage, what is it and why should it be considered? So you could say that it's an evacuation system that's built into conventional exit signage. And its aim is to improve the visibility of exit signage to provide the quickest and safest evacuation in an emergency situation. In doing so, it helps to improve the utilization of all available exits, reduces decision-making time, ultimately leading to an increase in evacuation speed. So where did the need for these systems come from? Well, this all came about off the back of years of research by Professor Edgar Lee, you can see on this slide, and his colleagues at the Fire Safety Engineering Group at the University of Greenwich. The FSEG is the world leader in computational fire engineering. The group and their advanced fire and evacuation modelling tools, Smart Fire and Exodus, have solved some of the world's toughest fire and safety engineering problems. The 30-strong multidisciplinary team of mathematicians, physicists, behavioural psychologists, fire safety engineers and computer scientists have been pushing back the frontiers of this fast-growing discipline for 20 years now, undertaking unique combination of leading-edge research, large-scale human factor trials, and practical real-world consultancy. Now, with the active dynamic signage systems, there were lots of human trials undertaken, which was key to establishing the final outcomes from this research. So if we take a look at their findings, we could talk for many hours over their research and findings. In fact, currently I'm writing an hour-long CPD on active dynamic signage systems. Should anybody want to really delve into the detail a bit further another time. But for the interest in saving time today, one of the key findings of this research was that only 38% of people notice a static exit sign in an evacuation situation, which is an extremely low number. But when they did do so, almost all of them followed the sign, almost 100% effective. So there's one clear message from these findings, and that is if there's one thing we must do, it's to ensure that exit signs are as visible as possible in an evacuation situation. We all understand the importance of reducing evacuation times, as in a real-life fire evacuation, every second counts. We know that fire and smoke intensity can spread at an alarming rate. Listed here are only a couple of examples where occupants were not aware of where the exits were, and the results were absolutely devastating. Now, these are just a couple of examples, and we picked these because these were some of the examples researched by the Fire Safety Engineering Group, but unfortunately there are lots and lots of other examples out there. But yes, to look at these today. So the first one is the Station nightclub at Rhode Island in America. This was not a particularly large or complex building, but being a nightclub, there were, however, 462 occupants at the time of the fire. Unfortunately, there were 100 deaths and 230 people injured. Now, there were 4 emergency exits in total within that building, but the majority of people tried to evacuate through the main entrance because that's the way they came into the building and they were familiar with that escape path. The problem with that was that in less than 1 minute and 30 seconds, the entrance was completely blocked due to a crush that ensued during the panic. Survivors who were later interviewed stated that they were not aware of other emergency exit routes or exit doors. And this was reinforced due to the fact that some people during the panic used furniture to break windows near the main entrance to escape. The next example is the fire at Dusseldorf Airport, where unfortunately 17 people were killed and 62 people were injured. And again, this was due to the occupants not knowing where the exits were. So this brings us back to the requirement where active dynamic signage systems could be considered. So historically, we have been very good at detecting fires and warning people when to evacuate, but then leaving people to their own devices to find their way out using conventional signage. We've seen that it's not as effective as maybe we hoped it was, and some buildings, as we know, don't have effective signage in the right places and not compliant to the latest standards. So active dynamic signage systems, or our Clever-Evac system, could be considered to complete the circle, or be the missing link, if you like, through that evacuation process. So now I'll pass you on to my colleague Michael, and Michael will go through the details of the Clever-Evac system and also look at that research in further detail. So Michael, please, can you go through the rest of the presentation, please?
Great. Thank you, Steve, and good morning, everyone. So we see a Clever-Evac as that missing link in evacuation systems. There's many components within a building that will alert you to the need to evacuate, whether that be a fire system or an occupant warning system. But through the use of the Clever-Evac dynamic signage approach, we now complete that full circle in a systemised approach to ensure safer evacuations, and we'll highlight how important it is to do that at a very small incremental cost. It's still a factor that people want to consider in looking at these sorts of solutions. How much does it cost? But given the signs already need to be there, we're dynamically activating. We're also adding, we'll talk about it later, negative enforcement. We're doing all that, though, at a very small incremental cost and ultimately making buildings safer, coupled with the ability to test and maintain these products. So if we look at where this all began, and the journey started for us some nearly 10 years ago, really, when we started looking at active dynamic signage, and it was on the basis, as Steve said earlier, of world groundbreaking research done at the University of Greenwich and the Fire Safety Engineering Group. And then coupled with that, we've developed and taken a revolutionary approach to product development with our Clever-Evac dynamic signage, which looks at visual, and we'll also talk about audio cues using directional locatable sound to further enhance the evacuation prospects within the building. And as we said earlier, we'll demonstrate why we see it as the missing link in evacuation. Again, highlighting that you've got detection, occupant warning, but what tells you, what shows you the way out of the building? That's where we see Clever-Evac enhancing that approach, all at a very small incremental cost. And then we'll talk about how we can guarantee the system integrity and operation of the product by the ongoing testing and maintenance, and how we reduce that burden of the testing and compliance approach by the use of a systemised approach using our ZoneWorks XT Hive platform, which can automatically test the products to ensure maximum system readiness and guarantee that system integrity. So as Steve mentioned earlier, the Clever-Evac dynamic signage approach is underpinned by the research that Professor Gallia and his team at the University of Greenwich had undertaken over many years. And Steve alluded to the different trials that were done. But importantly, there are two critical aspects that we'll be looking at this evening, and that's the two signs at the bottom of the screen there, the dynamic sequencing green sign there, sequencing the arrow. And we'll also talk about the need to have negative enforcement when that's necessary, when there might be an event in the building. So we'll talk about both of those aspects. But essentially, once we dynamically activate the sign from what we call affectionately dynamic green activation, we saw the results of the studies that 77% of participants actually noticed the signs, whereas with a static non-illuminated sign on the wall, only 38% of participants saw those signs. Importantly, of course, everyone knew what that meant when they saw them. So the point here is it's all about making them more noticeable, making sure that people see them, because if they don't, there's a chance that they won't realise there's an exit available. And Steve highlighted some tragic events that occurred in various building scenarios with the two examples earlier in Rhode Island and Dusseldorf Airport, where people did not notice the exit that was available to them. And so this is what underpins the dynamic green sign, and we'll talk about some of the specific parts of the product range a little later. But further to that, we're going to talk about the need to potentially block an exit or negate an exit for use that could be for several different scenarios. That could be a fire event, it could be a security event, dare I say, it could be a terrorist event. It's something that we don't like to talk about very often, but it's a real scenario that needs to be considered. So when the University of Greenwich underwent trials, they looked at the various methods to negate a sign. And you'll see here that there were fairly low recognition or understanding of these particular scenarios, whereby the red cross in this instance is placed beside the running man just over the arrow, or you've got this elliptical component with the line through it. What does that really mean? So that was not well understood, and you can see the results there being quite low. But when the negated sign that had the best interpretation and recognition is the sign with the large red X through the center of the sign. And you can see here from the numbers in front of you, a significant uptake in recognition, 84%, which means it's by far the most effective. Incorporated into that is the augmentation of the flashing LEDs in the corner, drawing your attention further to the design, but more importantly, the ability to put the red cross across the entire element of the product. And ultimately, this was the only configuration that performed to this level. And hence why it underpins the way we have developed the product in our range, which you can see here. And when we talk what is Clever-Evac is taking that groundbreaking research into sequencing of the LEDs under the arrow. It's important to note that they are high intensity green LEDs that are activated to ensure the sign is more visible than would be otherwise. Then you've got the red cross, as we determined earlier. Now that is actually an invisible red cross under normal operation. It is not visible. And we'll show some real product examples in subsequent slides that aren't animations, they're the actual product. And all of these products are available with the directional locatable sound option. And we'll talk about that in more specific detail on the following slide. But some other points to note is that all of these products in emergency mode, or power fail mode you might call it, each of those configurations support the 3-hour duration as required in the United Kingdom. It's also important to note the fail-safe sign condition, meaning that if something was to occur that rendered these signs inoperable, they are then at worst an ordinary exit sign and are visible. That's important to note. There are other approaches that we considered and that we saw were done in the market, whereby you could have some sort of display or OLED displays. We looked at all sorts of things, but those sorts of approaches don't have a fail-safe condition. Typically, the sign could fail off, and that's a lot worse than at least the sign not being able to illuminate or activate its function and it just being a static sign. So hence the importance of a fail-safe solution. People often ask, do the red cross versions of the sign also have a dynamic green mode function? And yes, they do. So there's actually, and we'll talk a little later again in the specifics of the product, the ability to activate that sign in either dynamic green activation or the red cross negation mode. And the locatable sound is available as an option on all the signs and their configurations. So a little bit more about the locatable sound technology. This is where you can hear the exit. And we originally embarked on this back as early as 2006. And the product at the time was Sound Escape. And so Sound Escape now is part of the Clever-Evac product suite as an addition that could be made to any of the signs we saw on the previous page. And it's all about where you can hear the location of the exit via directional locatable sound. There can be reasons why an exit is obscured. It could be something's been introduced to obstruct the exit, a physical structure. It could be a very complex building. And even with the dynamic signage, it could still be difficult to navigate the building. So hearing that final perimeter marking point, the final exit point, is important. We see the use of this product typically in that application where it might be the two internal fire stairs are marked within a building with the sound escape directional sound product, or as I said, sort of the final exit points of the building is a perimeter marking solution. And it would be a complementary approach to the dynamic activated visual signage. The research behind this product goes back into the late 90s, and a Professor Deborah Withington at the University of Leeds worked on this product, and she was a professor of audio neuroscience. And she was interested in how the brain responded to audible cues to determine the direction. And ultimately, the science proved that you needed three components to the sound: a low, mid, and high frequency component, because the brain processes low frequencies to determine direction by working out the timing difference that the sound arrives at each of your ears. Again, it's another reason, all of this points to why we've got two ears, to be honest. And then high frequencies then are determined we determine direction by the intensity difference between each of the ears. Again, the reason we've got two ears. And then, of course, looking at the mid level frequencies, there was a fancy term called the head-related transfer function. But in simple terms, it was the shape of the ear. And that's the reason we have ear lobes, helps to determine direction of the mid frequencies by how the air travels around the ears into the ear canal. So it's important to note that all three components are required to truly indicate direction of a sound. And our brain is processing all of these even though we don't know it. And hence there's some very serious science behind why directional locatable sound works and how it's used, which is just as serious, as the science that's behind why the dynamic activation of signs works, and including what was the best approach to a red negated cross solution. So if we now look at the real product itself in a real live demonstration. So we've recorded this previously of a demonstration board that we've used previously in different sorts of shows that we've demonstrated at. And here we're going to look at the static building scenario, then an activated green scenario where all signs are activated. And then we move into a scenario which meant that part of the building needed to have the red negated cross for negative enforcement. And then we've switched the input to the product to show that we can activate that on the other signs. Now, as a comment here, you can see that these are set up for the Australian-New Zealand arrangement where those two exit signs on the left and right are just the pictograph, the running man element only, which is the requirement above a door. In the United Kingdom, that would be an up arrow. Some years ago, that would have been a down, but these days it is up, meaning exit forward. And the reason we showed the different switching input was show you the activation of the signs, which can be manually activated via switch. Like tunnels, for example, often use a manual intervention of control panel switches. Typically, though, this is an occupant warning or particularly a fire detection system that would have specific fire matrix programmed into the system to activate groups or individual signs on specific events that might occur, with often a manual intervention element as well. And you can see here that each of these signs are truly the dynamic red types that also have the dynamic green activation, and of course the static mode as you see here. And most importantly, the dynamic red or the red cross scenario is not visible under normal operation, nor is it visible under the dynamic green sequencing. And that's critical to the outcome. You don't want to create confusion by being able to see other aspects of that sign when it's in another mode. Professor Gallier's research spent so much time on looking at what was the right combination to ensure instant recognition as much as possible and instant understanding of those signs. And we didn't want to interfere with that. Hence, we've gone to great lengths with very specific specialized technology to make the red cross invisible, but of course, extremely visible when activated. In fact, it's the only product that we're aware of in its class that does all three: static, dynamic, and the red negation of the cross in the way that it does with the dual inputs to the product, and delivering it in a way where it's as visible as it is when it's activated, but invisible when it's not. And that we see as the secret to the product design and application that we've done to take active dynamic signage into a real product solution. So going back to something that Steve said earlier, that we do see Clever Evac as being the missing link, again, at that small incremental cost to the whole approach of detection, occupant warning, and then evacuation. And again, that small incremental cost, because you still need the signs. Typically, we're not adding signs to the installation, we're adding functions where the signs already need to be there, hence the incremental cost component. So we'll move to some examples of how the product has been applied by fire safety engineers. And this is actually a real example that we've taken where a fire safety engineer, and look, this has happened on countless occasions, has had a requirement to add a dynamic red function, or I should say the red cross function, to negate the use of a particular exit in the building. And in this particular scenario, the green stairwell in the bottom right-hand corner discharged external to the building, whereas the red stairwell discharged internally. And in that instance, you've got the red crosses in front of the signs leading towards the red exit, and then you've got the green approach leading to the exit in the right-hand corner. And this is just that same scenario flipped around, and gives you a bit of a better visual indication by use of the arrows. So in this scenario, you've got stairwell 2 being the exit that's available. You've got the sequencing green LEDs running to any sign pointing to that exit, and you've got the red cross negated to stairwell number 1. Plus, in this instance, we've said that the directional locatable sound is active on just this product up in the top left-hand corner as the perimeter marking exit to that final doorway. So again, how are these activated at the lower level? So now we're moving into more some of the technical requirements of activation. So this is the fire services component. Once there's been the need established for the product, this is how it's specifically activated. So we've got when there's a fire detection event or other system intervention, which could be a security style event. It's not exclusive to fire. Then each of the products have a direct hardwired connection facilitating activation of dynamic green. And of course, in the case of the dynamic red sign, it's got 2 inputs, one for green and one for red. Okay. Furthermore, the directional locatable sound component can be configured usually to operate with it in combination with the dynamic green activation. So here we've got an addressable fire system showing you the detail where from an addressable relay module, we've got an output there wired as volt free or 24 volt. That'd be volt free the way that's drawn there. To these 2 particular signs that would be in a particular scenario where if activated, we want dynamic green on the sign on the left with the directional locatable sound, and the one on the right would be red cross. And in that instance, usually no sound. That would just be the red cross. And in that instance, you could actually daisy chain that connection between the 2 if there was only one scenario that you needed to deal with. However, if you need to deal with multiple scenarios occurring due to different events, you can have an instance here where scenario number 1, all 3 signs are activated dynamic green. They may also, in that instance, bring on the directional locatable sound. However, if something else occurred in the building, the fire matrix programmed to the addressable fire system would then activate what we'd call scenario 2, where the sign on the far right would go into the second mode of operation, being the dynamic red, and you can see the second set of inputs wired to that product. So you've got one output wired to products 1 and 2, and product number 3 has 2 inputs wired to it, a dynamic green activation and separately dynamic red, and in this instance, scenario 2 is taking control, being dynamic red. So that gets into some of the lower level technical details of the operation. We now move to how we systemize that with the use and integration of the Clevertronics Clever Evac product into the ZoneWorks XT Hive platform. Now, tonight isn't really about XT Hive, but just as a quick background, it's our addressable testing system for emergency and evacuation luminaires. And it performs automatic testing in line with the BS 5266 requirements. But importantly, and the focus tonight is, it also tests the Clever Evac enhancement LEDs, whether they be the dynamic green activation or testing of the dynamic red. So you're able to produce your test results, faulty fittings reports, electronic logbooks, resulting in a complete integrated system. And that's the whole focus here, is about systemizing this to ensure that we've given you these great products that ultimately improve evacuation outcomes through dynamic sequencing of the LEDs for positive enforcement and the negative enforcement with the Red Cross. But we've now helped solve the burden that typically comes with compliance and testing by being able to automate the testing process. So it's all about guaranteeing that system integrity, that the product's ready to operate when needed. And a bit more detail on how the product is tested. To test the dynamic green function, the product is activated and run in emergency mode for the full 3-hour duration, and then assessed for compliance. To test the dynamic red, any of those signs actually go first into a 1-minute function test to ensure the dynamic red illuminates to check it's functional. However, going into that mode can cause issues and concerns in the building of activating red signs when they're not needed. So we do it for a minute and then follow up with a full duration test in dynamic green mode. However, we have an algorithm that has worked out how long the product must last in the dynamic green mode to ensure that it can meet the requirements of dynamic red for the full 3-hour duration. So it's an important thing to note. And finally, for those who may not need or want a complex system integrated with the fire platform, and they're only looking for dynamic green activation, the ZoneWorks system itself, the ZoneWorks XT Hive platform, has the capability to automatically activate the dynamic green functions. Now, it could be that they activate on power fail, but we can also activate them with an input from a system, whether it be the fire system or manual intervention, to one of our controllers that can then broadcast to activate all the dynamic green functions when you simply want an activated enhanced dynamic signage outcome, and you would not have to go to the complexity of integrating it with the fire system solution at the individual product level, that is. So we move now on to looking at some of the real world examples of where this has been used, and we've depicted a number of different projects here, some fairly high profile projects. Largely most of these are Australian based ones, and you can see here we've covered aged care facilities where we've listed the engineer, Copper in Sydney, the Queen's Wharf development, a very big casino development on the riverfront in Brisbane, where the dynamic green product is being used extensively on that project. The Palace Cinemas in Como, it's actually a more complex job where the dynamic red cross, the dynamic green and red cross solution was used on that job on theatre type exit signs, where they're the black background sign that are used in Australia in particular for low illuminance areas like cinemas. We've got a train station there in London, which is actually a train station, Stanford La Hope, which is actually the station for the Tilbury Docks, where that project was done. And you can see C2C were the consulting engineers involved in that project. And another casino development on the Gold Coast this time, where both the dynamic green and dynamic red functions are being used, all as part, and I could say all of these jobs were used as part of an overall fire engineered solution, where the fire engineers were looking to solve particular evacuation problems, and they saw that the Clever Evac product was an important part of that solution. Which brings me to the final part of the formal presentation, and that is that this pathway forward, fellas, this new path forward for evacuation solutions is all about delivering products underpinned by important research at the University of Greenwich. It's about visual and audio cues in products, but the focus here tonight has been more about the visual activation of these signs and how important it is to delivering what we see Clever Evac being the missing link in evacuation, at that low incremental cost, and further enhanced by the ability of these products to be integrated into a true system solution, being able to reduce the burden of compliance and maintenance by automating that testing process, guaranteeing that system integrity, and ensuring these products are available when they're most needed. So, Steve, I'll hand back to you and we'll run through some frequently asked questions and questions from the audience. Steve, I think you're on mute.
Can you hear me now?
Yes, I can.
Apologies for that. So yeah, hopefully the presentation was useful and shared with you the reason why so many projects are now looking at and specifying these type of systems. I'd like to take this point to remind you that you can ask questions on the Q&A icon at the bottom if you've got any questions personally yourself here today. So whilst we're collating those, we'll take a look at some of the frequently asked questions that we're asked when we're talking to our customers and clients about these type of systems. So the first one is the exit signs shown are not compliant to any standard once activated. So how do you address that?
Well, when the products are static, obviously, and you talked about activated there, when they're static signs, they're compliant to the requirements, whether that be in the UK for BS5266, and of course in Australia to the requirements of our standard here, which is AS/NZS 2293 Part 3. But when they're activated, typically these products are a part of a fire engineered solution or other performance solution to address specific issues around egress and evacuation. We mentioned they could be a fire event, security event, and that's a big deal. It's not just about fire, and could be used to improve the utilisation of exits. So typically then the activation of the sign is all about enhancing its performance. So although it specifically doesn't comply with the requirements, it's about enhancement, and therefore typically a performance solution can easily demonstrate how effective that is and how much better it is than the deemed to satisfy or the typical compliance solution. And as I think you mentioned before, there are moves in the UK where you and I talked about this earlier, and I'm aware of this as well, where there are standards committees looking at adaptive dynamic signage and potentially looking at how they might integrate that into the European suite and potentially international standards.
Okay, perfect, thank you. So the next question we have here is who typically would take ownership of a system design? Who makes the decision when a red cross should be used, effectively closing an escape route? I know this is something that people quite often ask.
Yeah, so I put the same answer here as the previous question because it is particularly around the red cross. It's not just an enhancement to make something better, it's actually changing the egress path in the building. And so that, from our perspective, is left to the fire safety engineer involved in the project who is looking to solve certain conundrums, or other consultants, security consultants, or other consultancies, and I don't want to give them names because they could come from different areas, that are specifically engaged for the building as building practitioners to look at the scenarios that they're looking to deal with and to ensure that they negate those exits in line with the scenario that occurs at the time, and then provide the alternate means of egress, hence importantly complemented by the dynamic green sequencing and potentially the locatable sound to ensure egress. But typically this is about that whole performance solution and scenario investigation dealt with by specialised consultants.
Okay, thank you. The final frequently asked question before we move on to the participant questions is, how do you test this system for duration, but also test functionality?
Well, as we mentioned in the presentation, the Clever Evac products can be tested as part of our automatic monitoring and testing solution, being ZoneWorks XT Hive. And we can perform the function test, the duration test. Again, for the UK, that would be 3-hour requirement. It includes the LEDs and the Red Cross. And I talked earlier about how we handle testing of the Red Cross, but also the next part of not just testing the performance of the products that they work for the duration is that there would be a need on top of that to test the activation, the triggering of the product, the interface with the other system, typically being the fire detection system. And that part would be a manual trigger. So you'd usually go and activate the fire trip signal of the different scenarios that you wish to test, and then go and visually inspect the signs that they tripped into that mode. At that point, though, you can take them out of that operation because you know through ZoneWorks that they're able to then last the required duration, typically being 3 hours in the United Kingdom.
Okay, thank you very much. So now we'll move on to the questions by the participants. But before we go into the questions, we do actually have Paul Meenan on the presentation today, and he was involved in the Stamford Le Hope train station. He's just clarified for us that C2C were actually the client. So thank you for the clarification for that, Paul. Thank you. So moving on to the questions. Do you believe that emergency lighting signage is problematic because they come in similar sizes off the shelf, when in fact should be larger in places or more architecturally sympathetic, i.e. not a sandwich looking box?
Oh, look, of course. I think exit signage is a difficult thing to deal with in the built environment from an architectural perspective, because there's often competing interests about how the sign needs to look versus even its size. So the size can be a problem, although I would agree that in a lot of instances the sizes should be greater. Obviously there are requirements within the standard already in BS 5266 about viewing distances. However, one could argue they're not great enough, because Professor Gallier's research showed that people don't typically see static signs to the level that you expect. So increasing their signs would no doubt help, but activating them is probably more important again. So depending on the scenario, I certainly know that Professor Gallagher and his group have looked at different projects where not only were they doing dynamic activation, but they were increasing the size of the sign to further enhance its visual impact. Furthermore, of course, you don't want signs just to be boxes on the wall. That's why, in fact, part of our next product delivery that you'll see from us over the next few months is a blade style exit sign that is also a dynamic green sequencing LED product and is also available with the invisible red cross function. So to deal with the more aesthetic requirements of buildings where a blade sign might be more applicable than just the exit box on the wall.
Okay, thank you. The next one is, does the activated mode cause a problem with compliance?
Well, as we said before, it depends on how you look at that. The activated sign is proven to be, as a green sequencing leg, better than a static sign. So does it cause a problem with compliance? I'd argue no, it doesn't if it's better. You just need to prove as part of a performance solution that it is better. And Professor Gallagher's research proves that unequivocally. And our product's been designed in line with those outcomes. So the only problem it will have with compliance, if someone who is so short-sighted as to not consider that the research proves that it's better. But yes, it would still need to be part of a performance solution because the prescriptive requirements, specifically, there isn't a way to test or evaluate it. So that's how I would say that, the answer to that one. The Red Cross, of course, is a different approach altogether. I assume we're not talking about that solution. It's a fire engineered application changing egress. But if we're talking about dynamic green sequencing, it's an enhancement. It's better than the standard approach. And the research proves it. And that's how you'd formulate your performance solution around it.
Absolutely, and I could also sort of reiterate that point. You know, when we've had people looking at specifying these systems, even here in the UK, when they're writing it as part, say, a Red Cross system, as part of a fire and engineered solution, we have access to the research that could be shared with them and the client to support the fact it's going to enhance the safety on that particular site. So it gives them confidence to write that as a fire safety solution into their risk assessment and consider that it is an improvement rather than a detraction away from the standards. And ultimately, like we say, there are IEC working groups and standard committees around the UK and across Europe who are actually actively writing standards as we speak. So it won't be long before standards are in place for that to obviously put a solution to that particular conundrum. So the next one is, do your VAC products have a long life batteries and warranties, same as your other multi-lighting products?
Yes, they certainly do. All of the Clever EVAC product suite use our pioneering lithium iron phosphate battery technology, in particular in the L10 range, our nanophosphate technology, and as such have the warranties in line with each of those product ranges of 6 years for L10, 5 years for CLP as our standard offering.
Okay, lovely, thank you. The next one is, does the sound impact on the fire alarm tone? So I'm assuming that's part of the soundscape range.
Yeah, there was a lot of work done in the research on this matter, and because it's a broadband locatable sound, the absolute output of the sound is at a lower a specific amplitude than, say, a fire alarm tone. And of course, they're still tones, even though they do modulate slightly. They're narrowband signals. So they can ever only be in one specific part of the frequency range, whereas the directional sound is a broadband sound. And actually, I noticed I didn't play you the sound earlier. You know what? I know it's a bit messy, but I'm going to go back to where that is in the presentation because I want to actually play people the sound who've never heard it before. So just let me set that up while I do it. Here's the sound.
Exit here. Exit here.
Now, that sound being broadband, as you heard, means it's got a spectral component that needs to go between a minimum of 800 hertz and exceed 8 kilohertz, and it's got to be fairly flat in that range. And as such, even a singular tone won't interfere with that sound, nor at the amplitude that we play this sound in real life, nor does it affect the person's ability to be able to hear and recognise the alarm tone. That's an important part to note, and that's explained really well, actually, in NFPA 75. So, and there was a lot of work done for the North American Fire Alarm Code to include it into that standard as an informative appendix about how you could use directional locatable sound and not interfere with fire alarm tones. And it's quite a good explanation for anyone to read.
Thank you very much. And the next one is, can EVAC be used in a terrorist situation in, say, a train station or an airport?
Indeed. And look, we made a segue to that a few times in the presentation. It's in those instances would be used not just for fire, but to deal with a situation where you've got an incursion into the building by an external threat, typically a person, or maybe it's not, maybe it's a device that is going to potentially cause problems within the facility. You need to evacuate people quickly and you do not want them to go down that particular pathway. Then the signs can be directly activated by other system means. The signs will be activated then in the relevant mode to determine the appropriate path of travel. And there could be some supervisory system looking over the top of this, determining the various scenarios that require a particular set of activations. So we see that as one of the applications for certain.
Yeah, for instance, actually in the UK, we're working with a football club who was hoping to install it this year, but obviously the situation has changed a little bit, so it may be delayed now. But they've got our ZoneWorks system installed, and they're going to install the Clever EVAC system. And when it's not a match day, it was going to work directly with their addressable fire system, but on match day they have match control, have visibility of all the different areas of the building, and they're going to take over manual control of that system for that particular instance and some other instance as well, because the hazard or the issue or the security situation could be a moving one. So people might want to then change the scenarios from 1 to 2 and then back from 2 to 1 again as that scenario changes through the building. So it can be run independently from a fire system to be used when there's a moving potential risk or danger in that particular building as well. Okay. Are the products available for challenging environments, say subsurface or tunnels?
Yeah, definitely. And in different styles of casings, weatherproof style or high impact products as well. We've actually used the directional locatable sound in tunnels, and we have another option to that particular sound. There was further research done with an alternate directional sound used in tunnels. And in Australia, we've supplied 2 different tunnels with the product, one using the sound that you heard, another one using this alternate sound that I referred to for tunnels. And we're about to fit a 3rd tunnel. And these are long tunnels. These are 6 or 7 kilometre long tunnels with, 85 to 100 different signs above the cross passage doors. So yes, we've already done those sorts of jobs, and they can also be using the, more importantly, the dynamic activated signage as well.
Okay, perfect. There's a couple more asking about it impinging on the fire alarm sounders, but I think we covered that off.
One thing that, and there's one about the sound there, can it be heard above other things? Well, to just deal with that while we're talking sound, it can be, because it's a broadband sound. If you get other sounds that are like the human voice, it's narrowband. You can shout as loud as you like and you'll still hear the directional locatable sound. Most sounds are narrowband or, like a tone in their type, and no matter how loud they are, there's always going to be part of that spectrum that is free that you'll be able to hear that directional locatable sound, and that's the secret to its success and the reason it can be applied so well.
Okay, thank you. There's another one here on a more architectural offer. I think we covered that, the fact that we're having a new blade type range being introduced in the next month or 2, which has the dynamic green and the red cross functionality. Should we go down? Let's have a look. Fire alarm tone again. Does the dynamic signage consume more energy than a standard sign?
Only when they're activated. When they're in their static state, which is 99.9% of their lifetime, they consume almost exactly the same energy as a standard exit sign, because really all they're doing is running the normal LED illuminated panel and charging the battery. And with the lithium iron phosphate, nanophosphate technology, those batteries have a high charge retention, so they just sit there doing nothing, and we require very little top up of charge to those batteries. So hence the energy consumption in those modes is the mode that consumes the most time still consumes the least amount of energy.
Okay, thank you. Does the Clever Evac have to be used with your system, or can it be just standalone wired to the fire alarm system?
It's certainly feasible and possible to standalone wire it to a fire alarm system, but then you've got the burden of manually testing that product. So you've got to go and put them into the manual test initiation via a key switch type approach, and then to manually record those results. So there's that onerous burden of the compliance requirement. So yeah, I can't lie. Yes, the product can be bought and you can connect it in that way directly. But we see the better approach, and the reason we put so much time and effort into systemizing it is coupling it with the ZoneWorks XT Hive platform to get that automatic testing capability to reduce that compliance burden and the time it takes to verify to the compliance requirements.
Perfect. Could the green and red X be activated together accidentally?
No. If you had, for whatever reason, the direct inputs to the product both activate at the same time from the external system, the red will always take precedence in that instance. So internally in the product, if red activates, red's on, even if the green input comes on. So that was important about the logic that we implied there in the event that there was some other accidental trigger of both inputs at the same time.
Okay, I'm just looking through the questions because there's some questions come through that we've kind of already answered with previous questions. Okay, how is EL integrated with the various dynamic? I'm not sure of the question behind that one.
How is emergency lighting integrated with other various dynamic signage? Just trying to think the context of that question.
Yeah.
I guess the emergency lighting still forms an important part of the overall solution. It's not just about the dynamic exit signs here. Of course, we're talking about an emergency lighting and exit signage, including dynamic signage application. So, of course, the emergency lighting still forms a critical part of, you must still light the egress path. You must light the evacuation pathway. And, of course, that's why this is still all part, and we go back to the systemised approach, that this is a system. It's not, there's exit signs, there's dynamic versions of those, there's the negated red cross component, there's the emergency luminaires providing the lighting on the egress pathways, which all complement each other, and hence why connected to then interfacing to the, let's say, the fire detection system, which may have other manual input, is an important ingredient to activate those products when needed. And of course, in the ZoneWorks XT Hive platform to test the emergency luminaires and those exit signs, including their dynamic functions. So I hope that that answered that question or highlighted the importance of that.
Okay. The next question is, has this signage been tested in a smoke-filled space? And if so, was it more effective?
Yes, the information that we've read and received about dynamic activated signage, and of course complemented with the dynamic sound, it is more effective in those scenarios. Obviously, it has significant bearing on what the scenario is, and dealing with fire smoke in those situations is always difficult to quantitatively assess the outcomes. But of course, you've got activation of a sign that's brighter than it normally would be flashing in those conditions, which is more visible in those smoke-filled environments, coupled with the fact that you've got the locatable directional sound, which had very specific studies done in smoke-filled environments, because you can hear the exit even when you can't see it. So yes, definitely more effective.
Okay, we're coming up to almost the 50-minute mark, so we'll try and scoot through some of these. Do we supply a weatherproof version?
Yes, we do. Yes, indeed. Both, and including we can do some weatherproof applications with the directional sound also.
Okay. Next one is, could the dynamic signs be used for security, i.e. clearing buildings?
Yes, certainly. And I see another instance there where it could be used for a COVID type scenario. Now, what that's referring to is that, and you alluded to it in your first part of your intro, Steve, is about utilisation of exits. In a COVID world that we live in, evacuation needs to occur in the most orderly manner possible, with the maximum spacing and separation of people wherever possible. And of course, human beings typically react to an emergency scenario by evacuating through the same way they came in. Now, by using the product's ability with dynamic signage to make the required or the evacuation pathways more visible, you will get higher utilisation of exits. And it's actually something that has come to our forefront in recent times with the current circumstance. So
Okay.
I think that goes hand in hand with the security question.
Yeah, absolutely. I know that I've had conversations with various airports where they've stated it could be quite useful for landside versus airside security in an alarm condition, so that if it's a false alarm, people don't have to traverse across the two boundaries. So it's been of interest in those areas as well. So keeping some areas separate to others as well, which could be quite an interesting application of that. How would the tone work with a voice alarm system? Has there been any testing done in that field with the voice alarm?
Yeah, again, when you're talking about because the voice system, again, is at a higher amplitude or output, it can be heard in combination with the directional sound, because a voice is very similar to tone. It's a narrowband output. At volume levels that you need to have for the occupant warning systems, which will be higher as a raw amplitude level than the directional locatable sound, you'll still clearly hear the voice. And again, the work that was done and ultimately included in the North American Fire Alarm Code sort of highlights this again. But okay, that was focused on a single tone, but the voice is still a tone. It's still a narrowband signal. And again, the amplitude is required. It's much louder than the directional sound, but equally, the directional sound is broadband. It's heard right across the frequency spectrum, so they both can coexist and can be heard at the same time.
Okay, thank you very much. The next one's more of a statement rather than a question. It says it's perfect for railways and acts as a emergency do not enter device, saving costs on these type of systems. I'm not familiar with those type of systems. I don't know if you are, Michael, but it's a very good point for those who are in the know.
No, it is. And there's also another comment that was raised here that Clevertronics ensured that we added to the directional sound the short noise, meaning the exit here, or meaning come this way, because it makes all the difference with that directional sound. The part of the concern with the original concept was not the fact that it was directional, it was the fact that people didn't know what it was, that shh. So hence we make sure that our solution always incorporates the comment like exit here, for example, and that can be modified to suit the requirement. But as a perimeter marking, usually above the door, exit here is the one most commonly used. And that was a comment that was made here tonight that it was worth us reiterating.
Okay, perfect. Next one is, can the sign be delivered in a triangle setup for a tunnel setup so people can see it clearly from both sides running on the small evac path?
Yes, absolutely. And we've actually supplied products similar in that nature where they're the triangular type, and we can have them dynamically activated as well.
Okay. The next one is, does Sound Escape help with the Disability Discrimination Act for people with issues with sight?
Indeed, it does. Interestingly, it also helps people with a reduction in sound capability too, which I'll come to in a moment. But certainly the reduction in sight, and we've had disability consultants approach us about its use and specific interest around its use for people who can't see as effectively as others. And furthermore, the point about people with reduced hearing, in fact, we had the fire safety officer at a university in Melbourne was extremely impressed by the product because he could now hear that there was a problem in a building by activation of the broadband directional sound, because he could not hear the fire alarm tones because they're narrowband tones. His problem with his hearing was in the voice range, in the 1 to 3 kilohertz range, which is our human voice. Plus, it's typically where the fire alarm tones and warning systems are activating with voice. And so he actually was lip reading most of the time. He was very good at it because he'd hear just enough to complement with lip reading, but he could hear the directional locatable sound and heard enough of it to be able to even work out the direction of the sound. So it actually works for people with impaired hearing as well in some circumstances.
Thank you. The next question was about the COVID type scenario, but I think you've probably covered that off now with making all the available exits more visible, so people aren't huddling or crushing through the main entrance. A comment on the announcement that Clevertronics has made to the directional noise is to include a short phrase to come this way or exit this way.
Yeah, that's the one I dealt with before, yeah.
Yeah, this makes all the difference to direction noise. The problem with the original concept was some people thought the direction noise indicated danger, hence to move away from it. So yeah, it's more of a complement to our range. The fact it includes the phrase to exit here or exit left or exit right.
Yep.
Okay. would this system be possible recessed into the ground as, for example, a 600 by 600 tile?
Look, those scenarios are all possible and feasible. It depends on the sorts of construction requirements, but certainly the way the technology works and the panels and the technical aspects means they can be incorporated into almost anything that's got a front face that is clear, because we can incorporate the decal requirements, the LED panels and the various control gear behind, or even potentially remotely if space was limited. So all of those scenarios are definitely possible. Just, it needs the project and the right application for it.
Thank you. We're down to the last two questions, so thank you very much for bearing with us. We're nearly on the hour mark. So the next one is, are the voice signs available in other languages?
Look, we've not produced them, but yes, they certainly are. These are voice samples that we digitise and then we can incorporate in the product. So any language that's required, we can deal with and we can supply.
Okay. And the very last question we're going to answer today is about cost differential between standard exits and the dynamic signage.
Yeah, this is an interesting one, because you've got to consider the installed cost, because that's really the difference, because you need the sign in the first place. So, Steve, I mean, I've got a number. Do you work on a particular number to describe the installed cost difference?
I don't, to be honest, because it does depend on the project and how we can apply the project, the systems and the luminaires. So I'll probably say, if there's a particular project in mind, please feel free to get in touch and we'll happily look at pricing for you and see if we can come up with a solution that's suitable for you and your project.
Yeah, because it's an incremental cost to the product, and it depends on the product we're using. But when you consider the install, it's not the sort of differential that you typically expect. It's much less than normal. But it really needs a specific project, because it has a dependence on the other number of traditional exit signs, non-activated, and the number of emergency luminaires in the job.
Absolutely. Okay. Thank you very much. So, well, thank you, Michael, and the rest of the team who have helped to deliver this today. But thank you all for you guys who have attended today. It really makes these worthwhile, and the fantastic questions. And again, we had a fantastic response to this. It's absolutely superb. So thank you very much. We will follow up with an email to all those who registered, so you have a point of contact, maybe answer some outstanding questions if you want to come back to us on that. But again, thank you very much for your attendance, and we'll speak very soon. Please keep an eye out on our social media networks, because we will be announcing which webinar we'll be giving next week. Okay, thank you. Have a good day. Bye-bye.